The assignment associated with the watershed delineation is to draw the boundaries for the watershed of Nogies Creek. And you're going to start at the north end, at the top of Nogies Lake, and work your way south to where Nogies Creek intersects Highway 36. It then flows into Pigeon Lake. This map has a scale of 1 to 125,000, and because of this, the contour interval is very large. It's 100 feet. So you can see in this location that we have a contour interval of, or an elevation of 900 feet. Notice it's in feet, this is an old map. And then we have an elevation of 1,000 feet. This means that above the 1,000 foot contour line, elevations could range anywhere from 1,000 to 1,099. So, and we don't know exactly what that is because we don't have any point elevations marked. And if we wanted to be sure, one way could be to look at Google Earth or a 3D image of an air photo, or go to the site and check it out for ourselves. This area is on the Canadian Shield, and as such the topography is controlled very much by bedrock. So when we're drawing the boundaries of our watershed, we're going to start off by identifying areas of high elevation. So we'd be looking for hills, which are marked by closed contours. And I'm just going to find a better color here. There we go. There. So we see a hill here, we have another one here, we have more surrounding it. But those aren't all of, another one down here, those aren't all of the boundaries. But what you'll also notice is that there is the river system that drains into Nogies, which consists of Nogies Creek, Crystal Lake, Nogies further south, Bass Lake, and another lake down here. Over on the west we have Union Creek, which is drained into by Venner Creek and Venner Lake. They are not part of the Nogies system. So somewhere in here is the dividing line between Nogies and Venner. So it is in here somewhere. So again, you would need, so in this case, you would need to look at the patterns that the rivers are making. And you want to be sure when you're drawing these boundaries that you don't accidentally include a lake or river that's part of the different system, like Venner Lake here. So your boundary on the western side will take into account the rivers that drain into Venner and into Union, and you want to include in the central area the ones that drain into Nogies. Conversely, on the western edge we have rivers that are part of the St. Croix system, the St. Croix Creek, St. Croix Lake, really original here. The creek goes way up to the north, and it drains to the west. So somewhere in here is a boundary between Nogies and the St. Croix system. There are some hills that you can identify, but not all of them. So you're going to be looking at patterns dictated by the rivers themselves. The overall boundary for Nogies will start down at Highway 36, loop around up to Nogies Creek at Nogies Lake, and loop back down again to Highway 36. Now notice in my diagram here that I have purposely cut across St. Croix Creek. That's not the correct answer. You will need to determine where the actual boundary is. So what I expect for a submission is a sheet with a line drawn showing the boundaries of the watershed. You can do that on a black and white photocopy, or you can do it on a colored copy, which is, both are available in D2L. What I suggest you do is get some colored pencils or highlighters and highlight the rivers that are part of the Venner system, highlight the rivers that are part of the St. Croix system, and highlight the rivers that are part of the Nogies system. And the Nogies ones are the ones that you're going to draw the boundary around. It'll just make viewing easier for you. Once you have done that, the next step is to work out the the stream gradient. So you'll need to refer to your notes to find the formula. There's also a handout on watershed delineation and stream gradient calculations in D2L. And you're going to work out the gradient from the top of the watershed, which is where the X is, X marks the spot, to the southern boundary. And that's supposed to be a straight line. Again, X marking the spot. The elevations for each point are provided in the question, and you will need to measure this distance off, work out what the scale is, what that distance is in kilometers, preferably, so you can use your engineer's scale. And then you will need to throw in your difference in elevation into the formula. Remember that your difference in elevation will be in feet, your distance will be in kilometers, so you'll need to do some converting. If you need any help, email me, work out a time that we can meet, and I can go over it with you. So I hope your Thanksgiving was great, and I hope you have a great reading week, and we'll see you when you get back. Bye-bye.